Good evening again, students. Now, we're going to be looking at Pascal. The reason we're creating this video is that we want to show why arrays, what are the uses of arrays, how they work. If you're having difficulty with this topic, I suggest you look at the algorithm courseware video that has already been created and to get an idea or feel of loops and how they work. Because when you're working with arrays, you tend to be doing loops, repeating a block of code, because you'll find that out later as we go through arrays and the uses and why we use loops as well. So we're looking at a simple Pascal program here. I'm looking at Lazarus in this course where you have already been instructed how to download Lazarus from the very first video and what it's all about. So let's get into this now. The first thing when you're going to write a Pascal program, you make sure you declare your variables. So to declare variables, you use var. Then you start to specify the variables you want to use. In this case, we're going to use some variables that we used for our previous algorithm, a simple one at that. One where we're looking for the width and the length of a particular room so we can calculate the perimeter of the room. Now, let's declare our variables. Let us say length, len for length, wid for width, and per for pair. Okay, and we will declare these as integers or integer. Let us also decide that we want to give the room a name. Alright, so let us say we're working on a particular block, so we say room 1, room 2, room 3, room 4, and so forth. So let us call this variable, let's call this location. Alright, let's say LOC for location, and we'll declare this of course as string since it will contain words, word characters or data type. So we have these four variables: len for length, short for length; wid, short for width; per for pair, for perimeter. And what will happen is that we're going to be using those length and width because, as you know, when you're calculating the perimeter of a room, you're seeking to find the length and the width to calculate the perimeter, and location is a string variable, which room it is: room 1, room 2, room 3, etc. So let's get to work. And again, we want to write this program to have user input. To go to write programs, especially for your SBA, so that the user can interact with the program. Alright, so let's have the user interact. So let's display a message to the screen, and we want the user to basically respond to a question. What is the length of the room? And in this case, having problems finding my keys here, yes. So as usual, we ask the question, what is the length of the room? And have a semicolon in the statement. And of course, we will put in read ln, open brackets, len, because that's the variable to accept the length of the room. Then we go again, right. And why I'm not using right line is because I actually want the cursor to remain in the same row when we're inputting the data. Now I must, forgive me please, I'm not focusing on grammar right now and spelling and all those things, which is a good thing to do. Right now I'm just focusing on the syntax and the construct and the logical accuracy of the program, right? So forgive me if I'm making any spelling errors, I'm not focusing on those right now. And then I ask again, what is the width of the room? And we close our bracket, semicolon, and then I put read ln, open bracket, and I put wid, short for width, as the variable that I'm using. Then no, I can start to calculate. No, sorry, I want to know which room is it. Which should I put? Let's put this at the top. Let's put this up here. Yeah, and right, and then open single quote. Which room are we working with? Let's use that for the time being. And usually I don't tell students that I put a space here after the punctuation mark or this question mark. I don't usually don't tell students that I'm putting a space here between the single quote and the question mark because I expect you to figure it out. Alright? So when you're writing yours, and I hope you follow along and don't just look at the videos or the courseware and just assume that by reading it and you understand that you're going to be able to do this. It may look simple, but write it. Download the compiler, install it, open it up, and write the program. Even if you're following step by step, it will give you a better feel as to what you're doing and allow you to get to that place where you can actually start to be able to write the code yourself. If you even want to practice without watching the video and you rewrite the same code and so forth. So in this case, which room are we working with? Let's put in read line, open bracket, and let's put in LOC, loc, sort for location. Alright, now that we have all our inputs, let's start to do some calculations. And now we're going to say PER colon equal LEN times 2. Let's work with this calculation for the time being. My cursor is jumping all over the place. Plus LEN times 2. Oh man, non-lock is off. LEN times 2. Let me put these in brackets. What's going on here? Oh boy. Come on. LEN times 2. And let me close this bracket and open it up here. I will say plus, open bracket again, WID times 2. This is another series of calculation. There's another way you can go about doing this, which some persons may prefer. You may say LEN plus WID and then you say times 2 outside the brackets. That's another option that you may choose to exercise, or depending on how you choose to express your solutions to your Pascal program. Alright, so that is what we have here. The perimeter of a particular room or any random room is the length times 2 plus the width times 2, because perimeter is actually, as we all know, the measurement around the room, and most rooms, especially those that are rectangular of nature, will have 2 length, 2 width. Alright, so now we say write ln open bracket single quote the perimeter of the room is, and I'll put per here, close bracket, semicolon. And I want to add a bit of information here just so the program can actually, the user will know what to do to end the program. So I put right line, open bracket, single quote, putting a message on the screen. Please press enter to quit program. And then I would read ln, open and close bracket, semicolon. So that ends our little program here for the time being. Alright, now let us I'm going to name this project perimeter underscore, and I put an underscore because I really can't put space. No, you really should not put space. Perimeter calculator. No, you should not put spaces when you're writing the names for the Pascal program. So let us run this. Let me bring this screen onto here so you can see the execution screen here. And let me compile and run this. Hope we don't have any errors. String. Okay, I have an error here. It should be colon. Alright, that fixes that. Let us go again. Alright, now let me bring the execution screen on here. Which room are we working with? Let us say room 1. What is the length of the room? Let's say it is 16, let's say feet. And what's the width of the room? Let's say it's 10. So that's easy to work through. Now you should figure out what the perimeter is. 16 times 2, 32, plus 10 times 2, and you know what you get. Alright, please press enter to quit. So that's our simple program there that we have where we're calculating the perimeter of the room. So I'm going to close the execution screen here. So it's a simple program that we have. Now let's put this into a loop, because that is where we want to work with, so we can start to see the impact of our arrays a little bit later on. So to put this into a loop, which I suppose you guys should be familiar with by now, let's say a for loop for x colon equals 1, 2, 3, and let me put 3 this time because I don't want to go too far. Do begin, and I'll go right here. That's the beauty of Lazarus. And I go here and press enter. You can see it automatically put in the end semicolon to end that loop statement. I want to indent these because it's good to indent blocks of your code when you're doing selection statements or loops. It helps an onlooker, another programmer, to look at the program and know exactly where the loops are, where the selection statements are, and the program looks a bit more organized as well. Alright. Now please forgive me, I'm not so concerned with the async of the program, I'm concerned more with the logic and the flow and making sure you understand what arrays are supposed to do. So let's run this again and see what happens, because we know now that the program should loop about 3 times. So we should enter different rooms. The perimeter should be calculated for each room depending on the length and the width. So let's go again. Let's see how this works out. Let's bring this back. And let's start to run this program. Compile and run. Oh, keep making mistakes here. I don't know why. Too tired of this all the night. Alright, so I need to declare x, because x is a variable we're going to use to go through the loop. So x is here as an integer, using x as an integer 1, 2, 3, should be declared here as well. So let me run this now. Alright, so here we are again. Let me bring this over here. Which room are we working with? We're working with room 1. And let's go again 16, or let's use another number 12. And let's say it is 11. So almost a square room. Alright, for the 6th room we're working with. Let's say it's room 2. And it is 25. And 15. We get the answer of 80. And the last one would be, which one we're working with, let's say 20 and 10. And, oh, alright, let me do this again. Let me close this. I made a mistake here on the last part of the loop. I called the location of the room 20. So I'm running execution again. Not good to do these things in the night when you're home from work and you're tired. Tend to make mistakes. Which room are you working with? Room 1. With the length of the room, 25 and 20. Which room are you working with? Room 2, the room we're working with, and it is 10 and 5. What room was it? Room 3, and this one is 15 and 12. And here we get the perimeter of the various rooms: 54, 30, 90, and so on. Alright, and press enter to quit. So we said the program did loop 3 times. So a simple for loop. So we're going to do whole 9 yards. Simple constructs, going to loops, and then we're going to convert these loops to arrays. Now, why are we using arrays and not arrays? Arrays basically are program constructs to simply store data, because each of these variables is simply just one variable: one length, one width, one perimeter, and of course x, and location. So all of these are just singular containers or memory allocations, singular variables. What an array does, it allows us to use same variable name but create indexes in the variable. So the variable, that singular variable now, let's say for example length, in this case, will have 3 compartments or 3 sections. So you have length compartment 1, length compartment 2, length compartment 3. So we can store the different length measurements for each room. Likewise width, likewise perimeter when we do the calculation, and of course location when we decide to say, okay, room 1, room 2, room 3. So an array simply allows us to store data, large volumes of data or multiple volumes of data, without using a whole lot of different variable names. Alright, so let us see also another reason for doing this. We have one for loop here, and let us this time create another for loop down here where we'll have the program loop and to produce the results for the array. Hold on a second, having a bit of difficulty here. Computer misbehaving a bit. So let's go. So let's get to work. Let's say for x colon equals, again, 1, 2, 3, do begin. Alright, the end semicolon comes in. What we want to do here is that we want to print the results for the different sections that we're going to look at without the array first of all. So let us say we're going to print now right ln the measurements for the room. So the right ln let's say pair. Let's go length first. Len. Oops, I'm gonna put these here. Brackets. len with perimeter and location. I'm going to put location first. I should do that. Put location first. And I need some spacers, because if I just run this, what will happen is that all the numbers and the variables will be conjoined. It's like one long flowing word. So I want to space them. So let me put some single quotation marks here. Let me space them 1, 2, 3. Just do some rudimentary spacing here. Separate that element. Do another one here. Then quote 1, 2, 3. Come again. I'm just creating some spacers. 1, 2, 3. I don't want to make this too complicated. I want to make sure it is simple enough so we can follow as best as possible. So these single quotes here are simply to space the variables as they are printed, so they don't look like one long number or so forth. And what I'm going to do is to create some header out here. So let's say I go right ln open brackets, put single quote location and single quote 1 2 comma, and then the next one will be length comma 1 2 single quote, then we go width comma single quote 1 2 single quote again comma perimeter. My brain sense the function is slow this evening. Exhaustion is not a good thing. Alright, so here we are. I need to put these in single quotes as well. So it prints the word, because I want the words to be headers for the different sections. So the single quotes for spacers and the single quotes also because I want the terms at the top to give an indication of where we are working. It's a little bit smaller so we can see this. Okay. Alright, I hope that isn't too small for everyone to see. So we told the computer to write line with a heading location and length and width and perimeter. You'll soon see why this is useful. Alright, there are other ways we can work out them as headings to use and space them, but that require some more syntax, some more construct that I really don't want to get into. I want to keep it as simple as possible right now. So let me space them some more. 1 2 3, and some more spacing up. 1 2 3, 1 2 3. Add some more spacing there. Alright, so let us see how this looks now as we're going to run this program. So let's run it. We have an error here. Right line location. Length. What is this here? Full stop. I thought that's the only error there. And let's see what happens now. Alright, now we are back in business. What's the room we're working with? Room 1. And let's say this is 10 5. And then now we have room 2. And this is, let's say 15 and 10. And this is room 3. And this is 25 and 15. And now this is what we have. Room 3, room 3, room 3. And of course we can see the different headings here as we have them. But what happens? We realize that the computer did not at all remember anything about room 1 or room 2 and their measurements. All it remembered was room 3 because we are using one variable. Now what we're going to do is to create or reconstruct this looped program into an array. So the computer will then have a location room 1, room 2, room 3 and the respective length measurements, which in this case will probably be 10, 15 and let's say 25, and the width measurements of let's say 2 and 10 and 15 and the respective perimeter calculations. So what we want to do is to prove why arrays are useful. Because many times, if you're writing a program, say for your school, and you have hundreds or thousands of students, or in some cases, a company which is dealing with millions of whether items or records of persons, vehicles, whatever the case may be, you need to use arrays because it will be very well difficult to expect a programmer to sit down and think of, let's say, 1,000 variable names. So this is where arrays become useful. So let us fix these into arrays. I'm going to remove this x from here because I don't want it to be a part of the array. So all I do here is put in this term now, array. Then I specify the size of the array, which is open square bracket 1 through to 3, because I want to have just 3 areas there. So length, width, perimeter would be an array of 3, index 1 to 3, of integer. So that is what is going to happen there. Likewise, location will be another array of same size, 1 through to 3, close square bracket, of string. And now the last variable that we're going to have here, I'll put x here. So I put x colon integer, because x is not going to be a part of the array, because x will only be counting here 1 through to 3. So x will be 1, then to 2, then 3. All it's doing is counting. However, we notice that we want to put these variables, length, width, perimeter, as a part of the array. Why? Because each of these, and location as well, each of these we expect to retain data specific to its calculation. There are going to be different locations. Each location will have its own length. Each location will have its own width. Hence, automatically, it should have its own perimeter. And we want to store all of those values for each location. Its location, its length, its width, and its perimeter calculation. X is what we're going to be using to go through the array. Because remember, in the first loop, x is going to be equal to 1, because we're telling x count from 1 to 3. For x, therefore, is equal to 1 to 3. So x in a for loop is going to be, first of all, 1. Then it's going to be 2. Then it's going to be 3. So what we should do now is to change each of these variables to the index for the loop. So when x is 1, it is going to, when this x is 1, it will be at the very first part of the array, location number 1. When x becomes 2, when it loops and x becomes 2 in the for loop, it will go to index number 2 in the array. And when x becomes 3, the last section of the loop, it will go to location number 3 in the array, because as far as the computer is concerned now, all of these variables, length, width, perimeter, and location, they all now have 3 sections, like a filing cabinet somewhat. And each of them will contain the same data type, yes, but a different value. Alright, so let me go and put put these here so that we can traverse the array properly. X and the width. This will take some getting used to, but with enough practice, it will become as easy as cheese. And of course, everywhere I have length and width and perimeter, I have to put x there as the delimiter somewhat, telling the computer, that when x is 1, all of these will be in the very first index. Location, length, perimeter, width, all of these will be at index 1. And then I also have to go down here and put them in accordingly as well. I hope I didn't leave anything up top. Alright, let me scout through a bit, making sure I didn't leave anything out. Because as much as having errors and debugging is a natural part of writing programs, I really don't like them much, especially when you're having a video instructing students as to what to do. You don't want to make too many errors. So alright, I'll take this line out because this line is no longer necessary, because the first loop will simply be reading values into the array. Alright, the second loop will be outputting values. What else? Am I forgetting anything? Scouting to see if I can make sure. But anyway, if I have any errors, the computer will tell me soon. So let me run this program and see. Hope there are no errors. Alright, appears to be none. So let's get to work. Which room are you working with? Room 1. And let's say this is 20 of the length and it is 10 for the width. Which room are you working with? Room 2. And the length of the room is, let us say, 30. And the width is 15. Which room are you working with? Room 3. The length of the room is, let's say, 40. Things are going up. And the width of the room is 20. And now here we have what we expected. The location, room 1, room 2, room 3. The respective lengths for the various rooms that we entered them, 20, 30, 40. The respective width of each room, which was half basically of the length. So we have 10, 15, 20, and then the respective parameters for each room. So this is why we work with arrays. Because when you don't have an array, the computer will only the variable construct, will only have the last value entered when you work with loops. Only the last value that you enter, the computer will remember. However, and I'm using remember as a term because we can all relate to that. However, when you have arrays, depending on the size of the array, of course, you will have the computer be able to store all the values or appropriate values as you need to enter. Now, the last thing I want to point out is this. Yes, you can write arrays with other loops, until loops, while loops, but it is more easy to write an array using a for loop, because usually you have to set the size of your array, and for loops are specific in terms of the amount of times it will loop, not on a particular condition. It will loop a specific number of times. So it's much easier to use a for loop with an array for that simple reason. Alright guys, I hope that was not complicated or too difficult. You might need to go through it a few more times to get a good feel of it, but that is basically how we convert simple loops to arrays. I hope you found this Pascal tutorial informative. I hope despite the few mistakes I made, that you were still able to figure out what we're doing and to still keep track and I didn't lose you in any way, shape or form. Alright, have a good evening, rest well. I'm going to go to bed right now because I'm very tired. Coming from work all the time and doing these videos. Hope you guys appreciate it. Thank you very much. All the best in your exams as well.